Okay, so this will be a project overview for a Rust Actix web service. This is an extension of the initial web service we made that was just Hello World. What we've added here is some functionality with a recommendation engine, which we've built with Pinecone. And so we've made our Rust function actually call that Pinecone API, which is a vector database. And we'll get into how that works more. Um, Overall, what we have here is we've containerized the web service, which allows us to capture external dependencies and increase sort of um, portability and ensuring that things stay the same. So when we pass this off, there's not going to be any dependency issues. Um, Although Rust has cargo, which maintains crates and cargo dependencies, if there were external dependencies, you'd still want to do a container with Rust that allows you to sort of uh, scale this or send it portable, send it anywhere, and it would work. We've also added some logging instrumentation that's helpful when you're trying to debug things. Um, but we'll get into Pinecone also offers some free monitoring as well, which is pretty nice. Uh, Usage monitoring. Okay, so let's get into the code here. Before we go into the terminal, let's just talk about this function. So instead of just sort of a hello world function, we have this asynchronous function index, and it's going to use a host index, which is given from Pinecone, and it's going to use an API key, which is an environment variable here. And all this is going to do is it's going to, in this instance, what we're doing is we have a cocktail recommendation engine. So it takes what we did was we loaded a bunch of cocktails into a vector database. And in the README for this project, you can actually see a separate repo where all that's done. But we used a pre-trained BERT tokenizer and embedder. And for a vector database, what we have is we just have a ID or an index ID, which is a cocktail name, and then we have a vector associated with that cocktail. And what that vector is it's just an embedded, tokenized and embedded version of the ingredients lists. And what we want is we want to be able to submit a cocktail name and get back cocktails that have similar ingredients so people can explore that space and effectively get recommended something that is like what they asked for. Uh, Pinecone also supports adding metadata. So we've also added, what bar is that drink available at and the location or city where that bar is. The actual logic itself, right now we have Rust doing a fetch. So with the input is going to be a cocktail name. Rust is going to call the Pinecone API to fetch the vector associated with that name. And then it is going to query the database based off of that vector for the top five vectors based off of cosine similarity to that vector. And this is pretty interesting because it allows you to get some pretty uh, results you wouldn't think of. This is a great database to showcase this because cocktails often have, similar ingredients, but they'll be named different things depending on how fancy the restaurant is. And so having something that's able to capture the semantic meaning of certain tokens really allows you to search that space and get some useful results. So once it queries the API, the Pinecone returns with a response API, and it actually looks like what we see below here. So um, it just gives you back the top five based off of the score. Of note, one of them is the drink itself, but that's because the drink itself is the closest vector to itself. So pretty interesting stuff. Right now a few other call outs. So we have this in a CI/CD pipeline. So on every push to main, we format lint test, and then we build the Docker image, which is a build artifact that can be sent and used as a backend anywhere. So tie this to a cloud EC2 instance, and you can run this service and have cocktail recommendation engine. I'll call out a few other things here. So once you get that JSON payload back, and this is done in Python in that other uh, repo that I made, but it allows you to make some pretty cool visualizations. And this is fairly quickly done, but you get the listing of all the drinks you get back by search. And there's a whole bunch of other queries that you can do with a vector database. You can do CRUD operations. It's pretty useful. And then last bit about Pinecone itself, it does give you this sort of free monitoring where it shows you how many compute units you're using, how many vectors you have stored. So it's pretty easy. It's a serverless offering that can link to your AWS account. So you're only paying for what you use. And I think it's quite cheap. So this is all together making a fairly complex and effective recommendation engine with very few moving parts, packaging it all up and having it as a continuously developed, continuously refined build artifact from a repo. So that's it for this project. Yep.